my friends, and welcome back. Mr. A here today, back with another Circuit Playground video from Mr. Hart. Today, Mr. Hart is going to show us how to code the Circuit Playground so that it can play rock, papers, scissors with us. In the description below will be a link to all the resources needed for you to go through this activity with Mr. Hart.
Hello, this is Mr. Hart with another episode of Recess at the Circuit Playground. We're actually going to finally get into the full challenge mode that I've been really excited to get us to. If you want to find out how to see the document that in front of you, you can follow this link, http://cs4ar.info/recesscp. Now the R, C, and P do need to be capitalized. You can also follow the QR code at the bottom. We will be working in the coding environment found on Adafruit's website, so makecode.adafruit.com. Adafruit is the wonderful company that makes our circuit playgrounds that we're using. Today's challenge, I'm so excited. We finally get to do challenges for real. I need you to come up with a way to be able to play rock, paper, or scissors. I got that right, yes. With your circuit playground. Now, I've kind of given some hints here. I had to use one input to tell the computer to go, meaning the computer's waiting, and I tell it I'm ready to play, and we play. And then I had, because it can't do a rock, a paper, or a scissors, I made this little icon to do a color code. So if it displays blue, it's going to show rock. If it shows red, it's scissors. If it shows green, it's paper. And I've even put an arrow so you can see what beats what in case you're not familiar with this pretty common American game. I will also say that I needed two variables this time, and I'm not going to tell you what they are. So at this point, I'm going to give you 10 seconds to hit pause. I'm going to leave this up so that you can have the challenge in front of you. You're going to need everything we've done so far to make this work. Or maybe you won't. Maybe you'll have a better solution and you can let me know. So pausing in 5, 4, 3, 2, 1. I hope you're paused. Just a little extra time. Okay. Did you do it? Did it work? Did you finish? I hope so. And if you didn't, it's time for me to show you how I did mine. I'm trying something a little new this time, so bear with me. That did not work. Boom. Okay, so these are the pieces that I use. If you want to see what they look like, that's fine. This might be another good chance. I'm actually giving you a hint right now. So if you want to pause, I'll give you another pause break. I needed both an on start and forever loop. I use the block set all pixels to a color. Pick random. Now remember, we've seen these before. The two variables that I said, set variable, I didn't use the change this time. If and the comparison statement, and then I used an input for on shape. Now I'm going to stop here for a second and say the bottom portion, play sound, play animation on button A and button B. Those are for an extra that I'm going to walk you through when we get there. And you will need more than some of these than others. Like you're going to need more than one set all pixels. But these are the blocks that I use. So if you didn't succeed before, but you want to take another go at it, here's another opportunity to pause. So right now, spend just a little bit of time. Hit the pause button. I'm waiting. 5, 4, 3, 2, 1. There's your opportunity. Okay, so I'm actually going to remove all of my blocks, and we're going to start over. And I need to make sure I'm sharing computer sound. Done. All right, so the very first thing I'm going to need to do is have two variables. Okay, actually, let's just delete all the variables and go in order. So the very first thing I'm going to need to do is I'm going to have an on start and forever. Now, one of the biggest challenges of this challenge is how do I keep the thing from just going forever? I need to have an input to let it know that it's ready. And that input is going to be our first variable. So I'm going to make, I think I called it game running in my last. You could say game ready. You could call it whatever you wanted. And it'll let you use characters such as like an exclamation point or a question mark that in higher levels of programming it might not let you, we're going to run with it. So game running at the one of the first things that we should say is in programming, if you use a 0 or 1 to represent on and off, actually it's off and on. 0 is always false, 0 is always off, 1 is always on, 1 is always true. If you're looking at things that are either false or true, off or on, 0 or 1. There's a whole lot of history there that I'm not jumping right into right now, and that's okay. But I just want to know that right now, game running question mark set to 0 means off. So set game running on start to 0. And what that's saying is, I'm letting the circuit playground that right now, I don't want you to run. Don't play the game until I tell you to. Okay, that's good. So at the very beginning, whenever I turn this on, we're going to do that. Now we're going to try to add the next part, which is how do we make it decide what it's going to pick? So the forever loop is going to be what lets it show which one it's picked. So I'm going to need to use my random block. Now, rock, paper, scissors has 3 options. And so I'm going to go from 0 to not 3, but 2. Okay, and I'm going to store that in another variable. This is going to be called CP's choice, right? So it's going to be where it stores a value for rock, paper, or scissors. So I'm going to add a question mark, and I'm going to set, so forever, we're going to do that. Okay, so remember, we're building this in steps. This is not good code yet, and it won't be good code for a while, but we can see that right now it's going, you're going to choose 0, you're going to choose 2, you're going to choose 1, you're going to use 2, you're going to 1, because our forever loop keeps going over and over and over after the on start runs. Okay, so we've now picked one of the icons. Now I want to display that as an option, but we're going to make a comment. This is going to be a very useful comment for us. We're going to say CP's choice variable. This represents our circuit CP's rock, which is a 0 for blue. Yes, that's correct. Paper, 1 for green. Scissors, spelled correctly maybe, which is a 2 for red. Now, the reason I say 2 for red, 1 for green, 0 for blue is we're having to be very tricky because rock, paper, and scissors are icons that we're representing inside the circuit playground with a number, 0, 1, or 2, but we're displaying it as a color, blue, green, or red. And so this is one reason that comments are really great, because they really let you go, this is the thing that I'm doing. This is what's happening so I can keep it all straight. So if, for example, when I picked a random, if I picked 1, that means the computer is picking paper and it's going to display green. Okay, now that it's picked it, we should be able to display the right color. So we're gonna set all pixels to red if it's scissors, right? So let's say we have picked, it rolls a 0, we're gonna want blue. That's great, but that's just gonna pick a number and then make everything blue. I have to like let it think. I need some logic. If it picks a 0, then set everything blue. That if is our conditional. It's found in logic. We're going to grab this. I did want to point out something that I've never really hit, that this little plus lets you add more else's and if statements as you go, and the minuses let you take them away. It's because sometimes you have to go if this, oh no, then do, oh no, this one, no, else, okay. So in this case, if something, once again, we need our comparison, pretty standard hexagon thing that goes in there. If something equals something, well, if our CP's choice, which represents what it picks, is equal to 0, set it to blue. All right. Now, what's going to happen is it turned on blue immediately. So we thought, because it's running really fast. Oh, wow, that was a mistake. So what happened is that there's no other option. As soon as it hits 1, it's going to be blue and there's no other option. But CP's choice doesn't have to be a 0. It could also be else if, and we're going to duplicate this. If it's actually a 1, we're going to set all pixels to green. I'll wait for it to reload. Now we're starting to have a little bit of a disco effect here, because what's happening is this is running over and over, forever loop, over and over and over again. So it's, as it rolls a 0, it turns blue, and then it rolls again, and then it rolls a 1, and it's just going to blink back and forth. Now I will say, how many options are there? There are only 3: rock, blue, paper, green, and scissors, red. And if that's the case, we don't have to ask what the other number is. We know that it's going to have to be red. If it's a 0, make blue. If it's not a 0, then if it's a 1, do green. And if it's not a 0 or 1, then we automatically know it's the only thing left is red. Now, as you can see, we have a crazy amount of stuff going on because it's never stopping. This is the reason we have to tell it that we're ready to play. And in this case, is we need a larger if statement. If the game's playing, right? If we're ready. Now, as you can see, I can move this around, and I actually want to get it. Do you see right now that gray bar that's showing out how it fits around everything? Like, that's the gray part shows you where it is, and I want everything in that. And we're going to say if, we're going to need another comparison, except we want to know if the game's running. If game running is set to true or a 1, we play the game. And look what happened to our simulation. It stopped, right? Nothing's happening. Nothing's happening because we're never telling it to play. And this is why we need an input. This is me telling it I'm ready to play. So when I shake, right? And if you have a physical one, you can shake them and it knows what it is. Or on the simulation, you'll get this little button that says shake, or this is fun, this is cool. You can just do this really quickly, and that constitutes a shaking. So when I shake it, I want to then set the game to run to 1. So it's me saying, when I shake you, Circuit Playground, it means it's time to play. It's time to play the game 1 time. So watch what happens when I shake it. There we go. But it's doing it again, right? It's because we've told it to play, and then it never stops playing. And I only want to play, do I want it to play thousands of games before I can even figure out the first? No, I want it to do it once. And so what we're going to do, this is where we get to be real smart. We're going to come here after that first if statement. So after it makes all its choices, right? At the very end of it, we're going to set the game running to stop. Now what's happened is I shake it, it picks a color, and then it stops. And it doesn't do it again until I shake it again. Now, okay, I was getting a little worried when they were all green there, but remember, random numbers always do weird things. So as you can see, it'll stay blue until I shake it. And it may stay the same, it may not. So now I'm getting, the Circuit Playground is now picking. So like, if I go 1, 2, 3, shoot, and I do scissors, and I shake it at the same time, it just did paper, because that's green, I win. So we've made the Circuit Playground, basically we call it throwing rock, paper, scissors, right? Every time I shake it, it gives me something new. So this case, it did red, it's scissors. It does red, scissors, green, paper, red, scissors, green, paper, blue, rock. So now I can play it. So we've actually done what we were supposed to do. We've made the actual full thing. Now, if you'll remember before, I had a few extra blocks. So if this is all you care about, or if you want to pause it right now so you can get yours to look like mine, you're welcome to, but I'm going to add a little bit extra for a little flair. Now, the very first thing I'm going to do is I'm going to say that I'm going to tell it whether it wins or loses. And I'm going to do that with buttons. So on button A, that means we're going to put a comment. Circuit Playground wins. Maybe our Circuit Playground is not a very good sport. I mean, we all know those people, right? So it's going to be very excited. It's going to play, I like the magic wand sound, and it's going to play some animation for 5 seconds. 5 seconds means 5,000 milliseconds. Let's move that out of the way. Let's switch those. And because my computer is really loud, you don't have to do this. There's a set volume button, and I'm going to add that right here at the beginning, at the start. And okay, so if it wins, it plays the magic wand sound and shows an animation for 5 seconds. And I'm going to now make a different one that, and by the way, I just clicked here on the top of it, right click, duplicate, and it gave me a completely copy of everything inside. And then this is what happens if I win on button B. It's not really excited. It's going to play the wah wah and do the crash and burn animation. What is this one called? Theater Chase. Well, whatever. Okay, so we're going to play a game. Now, because it can't see what I'm doing, we're going to go ahead and say that I'm going to do rock. So we're going to shake it. It also picked rock, so it's got to go again. I'm going to do rock again. And it does scissors. I win. So I'm going to tell it that I win by pressing B. Circuit Playground's such a bad sport. But if it had won, it shows that it wins. Okay, I hope you've enjoyed this. I'm now putting corrected version solutions that may be slightly different from this one as part of that presentation. Really glad you stuck with it. This is hefty, I know it, but I'm glad you stuck with me. Anyway, have a wonderful day, and I look forward to seeing you soon.
Thanks, Mr. Hart. Parents and guardians, again, if you want to order your child a Circuit Playground, I've dropped a link to one vendor in the resources section below. Well, that's all the time we have for today, friends. We will see you real soon on our next episode of Computers Are Fun. See you soon.